Today I'm going to discuss the refrigeration cycle. This is technology that you'll find in many different applications on board. You'll find it in your provision cooling plant, in your air conditioning units. Shoreside, you'll find it in heat pumps, ice machines, many different applications. But for now, we're going to focus on the cycle itself and talk about the main components. So, the whole purpose of the system is to feed the evaporator with liquid refrigerant. Now, the evaporator needs liquid refrigerant because the boiling off of this liquid refrigerant is what creates the heat transfer. It's important to note that only when the liquid is boiling off in the evaporator is there a heat transfer from the surrounding areas into the refrigerant inside the evaporator. So the whole system serves this evaporator to provide it with that liquid refrigerant that it needs. So we'll start here at the compressor and we'll work our way around the system describing each component. So the compressor's duty is that of a pump. This pumps the refrigerant around the system. And it's important to note that the compressor only deals with vapor. It doesn't like liquid. So the compressor is pumping vapor around the system. It takes in a low pressure vapor, and of course, the output is a higher pressure vapor. Now, of course, as we increase the pressure of a vapor, the temperature increases, and we want to condense this vapor down in order to get that liquid refrigerant that we need. So we need to cool the vapor down in order for it to condense. And this is where the condenser comes in. Typically on board a ship, you'll find this to be a seawater cooled condenser. You can also have air cooled with a fan, or if you're on a yacht or something like this, you might find it with freshwater cooling if it's a more fancy system. But let's say it's a seawater cooled condenser, so this will be a shell and tube type condenser typically. So your high pressure, high temperature gas will go into the condenser, and as it's cooled down, it condenses into a liquid which is then usable, and we can use this to create a cooling effect inside the evaporator. From there, this liquid passes up to the metering device. So this metering device typically is a thermal expansion valve or a TX valve, oftentimes called, and its job is to feed the correct amount of liquid refrigerant into the evaporator in order to get optimum cooling. So how does this know how much to feed into the evaporator? Well, typically on the outlet side of the evaporator, we will have a bulb which is linked via a capillary tube to the metering device, and this bulb will give a feedback to this metering device to tell it how much liquid refrigerant the evaporator needs. It does this by measuring the superheat. The superheat can be set to a certain figure during commissioning, and then the metering device will always try to maintain that superheat. So if the superheat is too high, which means too much liquid is boiling off in the evaporator, it's boiling off too early, that means that we need more liquid refrigerant in to push the boiling off point further along the evaporator. Then more liquid will be allowed in. So then we have liquid coming into the evaporator, and the optimum is that at this point here, we have consumed all the liquid, and now we're only a gas or a vapor, which can then travel back to the compressor safely and can be pumped around again. As I say, very important to note, this point is critical where all the liquid is consumed. If we have a situation whereby the liquid is consumed at this point and now we have gas, we are continuing to add heat to the gas here, and we will find that we have a high superheat temperature here. Conversely, if we feed too much liquid into the evaporator, we won't consume all the liquid inside the evaporator, and we will end up with liquid coming out of the outlet and going to the compressor, which can cause mechanical damage liquid slugging, and other undesirable effects. If you'd like to know a little bit more about superheat, you can have a look at another video that I have on the channel. And if you have any questions, comments, concerns, please leave a comment in the comments.